To tell you the story, Impel started on the idea that trying to get drug across the brain, which is almost like a holy grail of the drug delivery business, and everyone wants to get into it. But our idea is it's really straightforward. The technology also is not the great challenge. So been there, done that with the large company, I always think of something straightforward that can be scaled. So the technology and concept is this, okay? We want to get more drug into the brain to get effect without loading up the liver and kidney, which are the site of toxicity, okay? So how do you get there? We can say, well, you know, these are privileged sites. You don't want to get blood into the brain tissues. You penetrate but perfuse to fuel your energy, but you don't get the blood cells into the brain. When you have that, it's bad things, okay? So how do you penetrate across that barrier? And so we need to think outside the box. Currently all the drug first go into the blood. You either orally taken or inject. It goes to the blood and then eventually cross the blood-brain barrier. But we says, can the reverse be possible? Can you get the drug into the brain first before into the blood? And if you can do that, then you reduce the liver has lots of blood vessels that perfuse, and the kidney also has a lot of burden, and those drugs that are supposed to be doing the job in the brain actually doing a lot of bad things in the liver and kidney, and that's where the toxicity that prevent things to be happen. So the wasabi moment, we all have that, right? If you take go to sushi, sashimi, you overload your wasabi, and then you get this vapor that travel to your nose, and then you get a brain freeze phenomenon. You can see these kids, just like your ice cream or icicle that you take in so fast, you get a brain freeze. Okay, so it doesn't involve blood. You can get there, and then anyone want to guess how effective through the nose that you can get things in? And we should be in the street drugs business, right? You can get in. There's no questions. How can you get in consistently in a controlled way? And that's really the bottom line of the idea, to think outside of the box. And so we created this. We look at what are the barriers and what are the challenges, and create this handheld disposable device to give you an active delivery with the control pressures. And then the questions then you said, well, does it work? Okay. So the challenge, obviously, is that if you take the traditional nasal pump, some of you have nasal congestions, like to use a pump to clear it. Mostly, you get in the nose, in the lower half of a third of the nose, and then the newer device that's available will get you about a middle part. And guess what? These will be all swallowed into your trachea and go into the gut. And we didn't know that until we really get into it. I'll show you the slides. And very few of these compounds will get on the upper nasal cavity unless you snort cocaine, dry powder with lots of pressure, okay, negative pressures to get there, okay, and plus cocaine obviously get this receptive. So it's harder than it looks because if you look at the nose from the top to bottom, you have a lot of these turboneck structures, and so not just simply just push it in and it'll get in. Even if you're trying to push it in, you will not get there. So we have to create a number of mortar and trying to beat the dead air space available up there, because that area is a dead air space. And so if you push too hard, you're going to bust it. Another reason why it will get in is because there are some of the neurons that actually penetrate through these these bone structures, and once you get in and be able to load up the drug up there, you can get more drug into the brain as in a first pass before it gets into the blood. And that's really where it is. And we've done this experiment using a radio-labeled glucose, glucose as the imaging agents in human studies. And this is done in primates, so overlapping the primate's nose and brain. And standard pump, if you can see that it mainly go into the lower nasal cavity. So this is your nasal cavity, and then with time, most of them are swallowed. Okay, most of those swallow, as opposed to this novel device that we invented. It allows you to go into the higher nasal cavity and stays there, and very small fractions actually swallow. And so with that, we can actually solve two things. One is the getting drug into the brain as a first pass. Because this radio label was too hot, we haven't readjusted. Actually, we can show that it goes into the brain in a couple other high resolution studies. The second piece is in the case like the Nasonex, other to clear the nose, we can then begin to clear the upper nasal inflammations and other things. And so we create a very different space of competitiveness, and we can look at biologic as well. In addition to analgesics, which in many ways takes time to induce the effect, onset of the effect, we can begin to think about getting these into the brain first before getting into the blood and reduce the side effects. Okay, and so opportunity exists for a large number of CNS drugs, including Alzheimer's, Parkinson's, brain tumors, and so forth. Okay, so the question is how we get there. Okay, to even get to this stage of paying for primary study, paying for the device development, and for me, I'm not very good at fundraising. I'm good at creating ideas, and so my role is to use that to leverage and translate into funding, non-diluted funding source to overcome this tether value of debt before you get commercializations and alignment with the large company for the new projects. And so how we done it in the brief sense is that my gift is in writing grants. So it's raising fund. In fact, we were able to raise fund through non-diluted, so-called non-diluted public funding grants, C4C funds, some of the early prototype work, and then the NIH fund, the significant amount of funding to develop these devices. And the Biodefense Army is interested in countermeasure against the nerve gas and other bio challenges, and neurological imaging funded by Washington Primary Research Foundation and Institutes for Health Research, and then acute pain funded by Life Science Discovery Fund. And so all these provide us the fund needed to get to this stage. And so we're now in the stage of trying to get alignment for, and then going through the human proof of principle studies and de-risk the concepts. Okay, so we're not out of the wood. We clearly have potential customers starting to talk to us. If our Department of Defense project works, we're now in the phase 2. So if it works, then they actually will buy and produce those products that hopefully one day the soldier will carry out into the field and will make an impact on their safety. And then we're talking to a number of drug companies, large and small as well. Looking back, how it get all started, the technology that we thought about, it has to be kept simple and practical. And then we need the people with passions and then alignment of the team. We were fortunate enough to have my graduate student, John Hoffman, and then Mike Haidt, who was at the time with a local company he has significant pharmaceutical interest, as well as he was going through the Foster Business School Entrepreneurial program. So we started with a young team, a lot of long hours that we worked together, and then supportive environment of C4C, and then the small check that they received, $25,000 on the Center for Innovation Entrepreneur competition program that they received, actually sealed the deal to get started. And so, yes, we are not out of the woods yet. We have gone as far as proof of principle, and we're in a stage of getting the proof of principle in human studies. And so we have a good anchor support by the LSDF, and so we need that mix public and private funding, especially in the case of current climate. And so this is where we are with Impel. What next? My role continue to be, I see myself as guiding them and building the collaborative team that we have relationship with university here, investigator as well as across the country to make that happen. And so we are gearing up to do the study in University of Washington with the analgesic program funded by LSDF, and then accelerating the clinical translations. So my role is to leverage all the resource available, financial or expertise or personnel, and we welcome collaborations in that, and hopefully we'll not run out of fund along the way. And so this is where it's very important to feed them out in your team, and so to speak. And so final thoughts, we are where we are because there's a institutional culture, supportive culture, and you know what, Seattle is a great place for collaborations, and that's what I came here. It turned out to be true, and the policy transformation in 2005 make it happen. And it is also a fertile ground. We have a lot of people who retire and make their bucks in the biotech pharmacies. They like to retire in the islands, and so you can go out to the islands and recruit these ex-Genentechs, ex-Amgens or current Amgens folks to help you in getting the things going. That they also come with it the talents. You know, university is a premier institutions with a lot of talented people and very nice collaborative environment. People will talk to you, and you can leverage their resource and time to guide you to make you successful. Okay, and then we do have alignment of the Foster Business School and the community here, scientific community, ITHS, among other, that help you guide your project going. I hope that you will learn from this talk how the universities has evolved with respect to starting up companies, fueling your innovations, innovative ideas into starting a company that will be successful, and what are the structures exist to help you to be successful at this new environment.